Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to quickly cover a couple of comets. Of course, the comet 12P Pons-Brooks was in the news quite a bit recently, particularly in association with the April 8th lunar or solar eclipse visible in the United States and other parts of North America. Here we can see that the comet 12P Pons-Brooks is still there. It's still very much on the inner part of its journey. We can see somewhere over here how far it is from us. Yeah, it's only a little further from us than we are from the sun. It's still closer to the sun than we are. 1 AU is the average distance between the Earth and the sun, so using AUs to measure things makes it very easy to say if it's closer to the sun than we are or further from the sun and how many times. So we can see here it's about 1.5 times further from us than we are from, about half further from the sun than we are from the sun. Further from us than we are from the sun. That can get a little bit confusing. So Comet 12P Pons-Brooks here, it's still close enough. It's still on the inner part of its journey through the solar system, but it's pretty much impossible for us to see it here in Ireland. We can see that it is setting before the sun actually sets for us here in Ireland. And we might also be able to see, you might be able to tell here, that it is very much below the ecliptic. So the line of the ecliptic is where we see the sun, the moon, and the planets. It's where eclipses happen. And luckily, looking at the sky here with no atmosphere during the day, we can see the ecliptic pretty clearly. If you draw a line of best fit, if you roughly draw a line trying to get as close as possible to all of the planets and the moon, it is a curved line. It does curve across the sky, but looking at the sky like this makes it look more like a straight line, because we're looking at a bit of a flat projection of what would be a curved view of the sky. So we can see that the ecliptic is pretty much here, going across the middle of the screen, and Comet 12P Pons-Brooks is way down there, way below the ecliptic. If we take a look at the orbital path of this comet, and we will be taking a look at it from the Earth here, we'll get a very, very big ellipse, very, very elliptical ellipse, a very eccentric ellipse, very squished looking, very long, if we were looking at this from above the solar system. But we can see here that the path of this comet, it's pretty much perpendicular to the ecliptic. It's not passing around the sun on the same plane as the planet. It's going above and below the sun. So this happens especially with smaller objects like comets, especially with objects that originate from very, very far out in our solar system. They can end up orbiting the sun outside of the ecliptic plane. They haven't been sort of stabilized into this nice flat disk, and there's a good chance that it may not have originated from the flat disk of gas around the fledgling sun. The same way Saturn has a ring, stars that eventually develop solar systems usually have a ring of rock and dust and ice around them that the solar system develops out of, and that ring usually follows the equator of the star, the same way the ring follows the equator of Saturn and the other gas giants. Comets often originate from a little further out. There is a cloud of objects around the sun in a more spherical shape that hasn't really been forced into the same flat disk as the things that are closer to the sun. So objects like this, they can end up orbiting a little bit differently, a little bit more inclined, more obliquely. All sorts of strange things can go on with these smaller objects that originate from further out in the solar system. We can see here as we move through time that the comet 12P Pons-Brooks is moving away from the sun and towards us. We can see just about here 1.546 AU from the Earth. That's about the closest it's going to get on its way back out, and we can see that it's now further from the sun than we are. If we move back in time, it gets closer to the sun, further from us, and if we move ahead in time again, it gets further from us and further from the sun, because it is simply leaving the inner solar system. Because the comet's orbit is so long, over 70 years, it takes decades and decades for this comet to get around. As it's leaving the solar system, the Earth's orbit will bring us closer to it and then further away from it. But on average, the distance between us and the comet is going to increase once we pass that point of closest approach, as it kind of swings near us on its way out of the solar system. And by near us, we can see there it's 231 million kilometers. So near is a relative term in this case. It's out of view for us, but if we were to travel to another part of the planet, the Southern Hemisphere, let's get nice and low. Of course, I could click anywhere down here. We're not we're not stuck to just using dry land in software like Stellarium. I could put us in the middle of the ocean and we could pretend that we were looking at the sky from a boat. But I do like to I like to at least imagine that when I am traveling to another part of the world, I might not have much viewership from the lower portion of Argentina and Chile, but just in case I do, this is what it would look like for people who are down there. Now, it is after getting a little bit further from the sun there, so I think I will need to bring things back just a little bit. Just in order to get it visible. It gets to around 5 from certain locations. We might be a little bit too low on the planet. Of course, closer to the equator, objects will appear to rise more directly from the sun. Things are a little bit different with this object because it's not following the ecliptic. But we can see here, around a magnitude of 7. In darker skies, that is visible the naked eye. So let's push out to the countryside here. Of course, in the countryside, the faint, still reasonably faint comet will have to compete with the light of many, many other stars. So we can see there, just above the horizon, should be just barely visible, at least through binoculars. Yeah, it's there as a little dot, and we can see its tail. The comet is currently leaving the inner solar system. It is moving away from the sun. And if we move through a few days here, it's hard to tell, but the comet is moving that way. It's moving to my right. So if you were standing on the comet, it would be to the left. It becomes a little bit more obvious here. We can see it moving out away from the sun relative to the stars. But its tail is also pointing that direction. The comet and the tail are moving the same way, away from the sun, because the comet's tail is generated mostly by the solar wind blowing bits off the comet and generating this tail stretching out behind it or ahead of it. In this case, it really is ahead of the comet and its direction of motion. The comet is moving that way. We can see the sort of double tail here. Different parts of the tail will be affected differently by different parts of the solar wind. Some of them are affected by the sun's magnetic field, depending on how much they're deflected by the motion of the comet relative to the sun. Sometimes comets can look like they have 2 tails, one pretty much stretching out behind them and one pointing directly away from the sun, but that varies quite a lot from comet to comet. I do want to make sure we get a nice view of this and go somewhere where hypothetically we'd have a good view. So let's pop a little bit closer to the equator here. And let's see what it looks like. As I've said a few times now, it is a really, really highly inclined object. So the way it behaves in the sky is unintuitive. It doesn't behave like the planets do. And of course, it's the planets that I am used to. So here we go, pretty much at the equator, and we can see that it's just barely above the horizon as the sun is going down. And let's see if it gets brighter at any point. Pulling back to here, you're getting very, very close to the sunset. Let's pull it back a little bit more. Here we go. So we're here at about a 4, which is usually quite visible to the naked eye. This was a couple of days ago, but we're not too far past it just yet. And we can see there, yeah, definitely visible. At least once we zoom in a little bit, it might be just barely visible to the naked eye. If you have a good knowledge of the stars that you should be seeing, you might notice that this thing is extra to that. So let's get rid of the names. Let's get rid of the line. Yeah, there it is. Definitely visible to the naked eye under these conditions. Just barely. So, especially if you're in the Southern Hemisphere, if you haven't gotten a chance to see this comet yet, which won't be back for over 70 years, if you haven't gotten a chance to see it yet, well, you do still have a chance. It is still there. It is still visible, but it is leaving. We're definitely coming up to the time where, if you don't get to see it now, you may never get to see it again. And it is going to be pretty much out for anyone who is in the Northern Hemisphere. We, unfortunately, don't have a chance. Now, that comet is barely visible. Even under great conditions, you can just about see it with the naked eye. Other comets are much, much more impressive. For example, Halley's Comet. Halley's Comet, I believe, is the correct way to pronounce it. Something always makes me want to say Halley's Comet. I'm not sure why, but Comet Halley, 1P Halley. There we go. And we can see 2061. That's when it's coming back around. That's when it will be near us again. Now, it's saying that my epoch elements are probably outdated. They're sort of predated. We haven't actually gotten up to 2061 yet, so of course predictions will get a little bit more accurate when we're closer to it, but that doesn't necessarily have to stop us here. In the next video we are going to travel into the future up to 2061 just to demonstrate what the comet would look like. So I hope you come back around for that video. If you don't want to miss it, make sure to subscribe to the YouTube channel. And if you enjoyed this further look at the Comet 12P Pons-Brooks as it leaves our solar system, or begins to at least, then do like the video. And if you'd like to read a little bit about this, you can head to my website, queevinscontent.ie. So hopefully I will see you next time.